Good morning, my dear children. Welcome back to the session 5. Already in the previous session, you have learned the laws of logarithms and some based on the laws of logarithms and some different models. And today, you're going to learn the other models on logarithms chapter, which is related to your textbook. The first model in this session, that is, evaluate in terms of x and y if x is equal to log 3 to the base 2 and y is equal to log 5 to the base 2. First example based on this. Log 7.5 to the base 2. We can write 7.5 as 75 by 10. So 75 by 10 the base 2. Now this is in the second law of logarithm, that is log a by b, which is equal to log a minus log b. So log 75 to the base 2 minus log 10 to the base 2. The prime factorization of 75 is 5 into 5 into 3, and prime factorization of 10 is 5 into 2. So write it here, logarithm of 5 into 5 into 3 to the base 2 minus logarithm of 5 into 2 to the base 2. Now use the first law of logarithm, that is logarithm of AB is equal to log A plus log B. So expand it, log 5 to the base 2 plus log 5 to the base 2 plus log 3 to the base 2 minus log 5 to the base 2 plus log 2 to the base 2. Now with minus, you multiply both the terms to the second part, then you will get it here that in place of log 5 to the base 2, the given is y, so write y. The next again log 5 to the base 2 is y, then log 3 to the base 2 is x, then minus, with minus you multiply, you will get minus y, then log 2 to the base 2, its value is 1. This is another law of logarithm, already you learned it. So finally we'll be getting the plus y minus y is getting cancelled. So the leftover is x plus y minus 1. So we have converted the given question in the form that is x plus y minus 1. The second one, the same model. Log 60 to the base 2. The prime factorization of 60 is 3 into 2 into 5 into 2. So use the first law of logarithm and expand it, that log 3 to the base 2 plus log 2 to the base 2 plus log 5 to the base 2 plus log 2 to the base 2. You already know that log 2 to the base 2 value is 1. So log 3 to the base 2 already it is given as x. So substitute x here, then plus 1. Then log 5 to the base 2 its value is y. Then log 2 to the base 2 its value is 1. So x plus y, and here 1 plus 1 is 2. So finally the result is x plus y plus 2. Next model, that is, if x square plus y square is equal to 25, then prove that 2 log x plus y is equal to 3 log 3 plus log x plus log y. This also we can do it by using the laws of logarithms. So the given is x square plus y square is equal to 25. This is an incomplete binomial expansion. So to make it into the complete binomial expansion, add 2xy on both the sides of this equation. Then x square plus y square plus 2xy to the left hand side, and to the right hand side 2xy to 25xy plus 2xy. Then the left hand side part is exactly is the expansion of a plus b whole square identity, that is a square plus b square plus 2ab. So we can write that as a plus b whole square, so that is x plus y whole square. And to come to the right hand side part, 25 plus 2 is 27, so we'll be getting here 27xy. Now we have to take the logarithms on both the sides. Then log x plus y whole square is equal to log 27xy. Now use the laws of logarithms here. Log a power m is equal to m log a. So log x plus y whole square, we can write it as 2 log x plus y, which is equal to, write it the 27xy as 27 into x into y. Now the prime factorization of 27 is 3 cube into x into y. Again, use the first law of logarithm, that is logarithm of ab is equal to log a plus log b. So expand it, that is log 3 cube plus log x plus log y. Then log 3 cube, we can rewrite it as 3 log 3 by using the law log a power m is equal to m log a. So finally, we'll be getting the result, that is log 3 log 3 plus log x plus log y. Now the other model. If 2.3 whole power x is equal to 0.23 whole power y is equal to 1000, then find the value of 1 by x minus 1 by y. Solution: 2.3 whole power x is equal to 0.23 whole power y, which is equal to 1000. This is given. Now take 2.3 whole power x is equal to 1000. We can write it 2.3 whole power x is equal to 1000 as 2.3 is equal to whole power x. If you transpose other side, it will become as to the power of 1 by x. So 2.3 is equal to 1000 to the power of 1 by x. We can write 1000 as 10 cube. So 10 cube whole power 1 by x. Here you use the law of exponent, that is law a power m whole power n is equal to a power m into n. So we can multiply 3 into 1 by x, which will become 3 by x. So that is equal to 10 to the power of 3 by x. Let us make this as equation 1. Now take the second part, that is 0.23 whole power y is equal to 1000. Similar way, we can write it as 0.23 is equal to 10 cube. We can write 1000 as 10 cube whole to the power of 1 by y, because the y is transposed to the other side, it will become as to the power of 1 by y. Now multiply both 3 and 1 by y by using the law of exponent a power m whole power n is equal to a power m into n. We'll be getting here the 10 to the power of 3 by y. We make this as equation 2. Now take logarithm on either sides of equation 1 and equation 2. Then we will get here log 2.3 is equal to log 10 to the power of 3 by x. That implies, let us simplify this one. That implies log 2.3 is equal to 3 by x log 10. Here there is no base, means I have already informed you that when there is no base given, we can take it here the base as 10. So we will write this as log 10 to the base 10. Here I used the law of logarithm, that is log a power m is equal to m log a. So that's why we'll get here 3 by x log 10 to the base 10. And you already know that logarithm of any number to the same base, its value is 1. So the whole thing log 10 to the base 10 will become 1. So finally 3 by x into 1, which is equal to 3 by x. Yes, you make it as equation 3. Now take the other part, which is equation 2, that is log 2.3, 0.23 is equal to log 10 to the power of 3 by y. Again, use the law of logarithm, log a power m is equal to m log a. We'll get here 3 by y log 10. When there is no base, we can write as 10. So 3 by y log 10 to the base 10. And log 10 to the base 10 value is 1. So you will get here finally 3 by y into 1, that is 3 by y. This is, you make it as equation 4. Now subtract equation 3 and equation 4, that is log 2.3 minus the left hand side part of both equations 3 and 4 are log 2.3 minus log 0.23, and the right hand side part of both equations 3 and 4 are 3 by x minus 3 by y. So again here we have to use the left hand side part using the law of logarithm, that is log a minus log b is logarithm of a by b. So log of 2.3 by 0.23 is equal to, in these two right hand side 3 is common. So if you take 3 common, the leftover is 1 by x minus 1 by y. Now again come back to the left hand side part. Logarithm of 2.3 can be written as 23 by 10 by, we can write it as the reciprocal, that is 23, 0.23 we can write as 23 by 100. So we'll write it in multiplication, the reciprocal of the second one, that is 100 by 23. So 23 is going to get cancelled, and 10 ones, 10 tens are 100. So finally the leftover in the next part is 3 by 3 into 1 by x minus 1 by y is equal to log 10 to the base 10, because already the 23 is getting cancelled over there, and dividing 10, 100 with 10 will be getting 10. So there is no base in that, so I have used again the base as 10. So log 10 to the base 10, its value is what? 1. Already you did in the previous steps. So finally, 3 into 1 by x minus 1 by y is equal to 1. Finally, 1 by x minus 1 by y value is transpose 3 the other side. So you'll be getting 1 by 3. Now, the another model in this chapter, that is from exercise 1.5. If log x plus y by 3 is equal to 1 by 2 into log x plus log y, then find the value of x by y plus y by x. You see just the solution of this question. Log x plus y by 3 is equal to 1 by 2 into log x plus log y. This is the given question. Now, transposing 2 to the left hand side of the equation. Then you see here, we'll be getting here 2 into log of x plus y by 3 is equal to log x plus log y. Now, here m log a, the law of logarithm, m log a, we can edit as log a power m. So, logarithm of x plus y by 3 whole square, which is equal to log x plus log y. This is also the law of logarithm, log a plus log b. We can write as logarithm of a into b. So that is logarithm of x into y. So now expanded this one, the left hand side part, which is in the form of, the numerator is in the form of a plus b whole square. So expand it, a square, that is x square plus y square plus 2xy by 3 square value is 9. So x square plus y square plus 2xy whole by 9 is equal to logarithm of x into y is xy. Now both the sides, the single logarithm is there, so we can cancel both. So when you cancel logarithm on either sides, the leftover part on both the sides is x square plus y square plus 2xy by 9 is equal to xy. Now the cross multiplication, by the cross multiplication, we will get it here that x square plus y square plus 2xy is equal to 9xy. Now transpose 2xy to the other side, then we will get it x square plus y square is equal to 7xy. Now here what we should do to get the result, divide both sides of this equation with xy. Then x square plus y square whole by xy is equal to 7xy by xy. Why we should do with xy? Because we need to get only the right hand side part, only the numerical value. So along with numerical x7, we have xy. So to get cancel xy, both we must divide it with xy. So finally, separate the terms in left hand side, x square by xy plus y square by xy is equal to, right hand side both xy are getting cancelled, so left over is only 7. Now you see once again the left hand side part, in x square numerator and denominator xy, one x we can cancel. Similarly, y square by xy, in both we can cancel one y. So leftover in left hand side part is x by y plus y by x is equal to 7. So the value of x by y plus y by x is equal to 7. Now the next model in the textbook is find x if 2 power x plus 1 is equal to 3 power 1 minus x. Take the given. The given is here 2 power x plus 1 is equal to 3 power 1 minus x. Now taking log on both the sides. Log 2 power x plus 1 is equal to log 3 power 1 minus x. Again use the law of logarithm, log a power m is equal to m log a. So x plus 1 log 2 is equal to 1 minus x into log 3. Now multiply x plus 1 both the terms with log 2. So x into log 2, that is x log 2 plus 1 into log 2 is log 2, which is equal to, again multiply the right hand side part also with log 3, that is 1 into log 3 is log 3 minus x into log 3 is x log 3. Then x log 2, now what we should do is transpose x log 2 to the left hand side and log 2 to the right hand side. Then we will get it here x log 2 plus x log 3 is equal to log 3 minus log 2. Left hand side in both the terms x is common. So to take x, if you take x common, x into log 2 plus log 3 is equal to log 3 minus log 2. Therefore, x is equal to, so the log 2 plus log 3, which is in the product with x, will go to the right hand side. So it will become that finally log 3 minus log 2 by log 2 plus log 3. This is the value of x. Now, the last model in your textbook, exercise 1.3, that is log 100 rational or irrational? Justify your answer. Let us see how we are going to prove that whether it is a rational or irrational. Let us take that log 100 when there is no basis given. I already said we can take the base as a 10. So log 100 to the base 10, we'll assume it as some variable that is x. Now convert this logarithmic form to exponential form, then we'll get it here 10 power x is equal to 100. We can write 100 as 10 square. Then since bases are equal, we can equate the powers, therefore x is equal to 2. So we got the value for x we got some value which is a rational number, so it is the given, that is log 100 is a rational number. So very important note in this logarithms chapter, that is the integral and decimal part of logarithm. If you don't have this in your exercise sums, but it's very important to learn. So I am just giving this important note. What is integral and decimal part of logarithm? Example, you take, suppose log 2 to the base 10 value is 0.3010. So in this, the zero, the left hand side of decimal is zero, which is called as integral part, and 3010 is called as the decimal part. Now, the decimal part, including decimal, that is 0.3010, together is called as Mantissa, Mantissa. This is very, very important, children, to learn it. Now, we have come to an end of this chapter, that is logarithms. I hope you might have understood everything that what you have learned in the logarithms chapter. Please once again go through all the modules, means all the sessions which you have learned on this particular logarithms chapter. It's very, very easy to understand and very, very easy to practice, children, my dear children. So practice well and keep everything in your mind, so that these all models which are explained are very, very important for your examination point of view. Thank you very much.